Hello. In this lesson, we'll be going over solutions to inequalities. So as a review, inequality symbols are used for two main things. First, to compare numbers. For example, 5 is less than 10. And also to represent multiple numbers. X is less than 10, so this represents all numbers that are less than 10. Right? Represents multiple numbers. And so what is a solution to an inequality and how can we think about it? And so let's remember the solution to an equation, when we have something like x plus 1 equals 5, the solution, it's the only way that makes it stay balanced or equal, right? So when we've been doing this, we've been subtracting 1 on both sides, we've been showing this visually as well, and then we've been crossing this out to match it up. 5 minus 1 gives us x equals 4 pounds. So this 4 pounds, that's 4, it's the only one that keeps this balanced, right? So those are equal, so that's with an equation. With inequalities, right, now we have this entire x plus 1 is heavier than the 5 pounds, right? So if you think of that visually, if you see this x plus 1 over here, right, that is lower, so that means it's heavier than all of these ones. And so when we solve this, right, what does that solution mean? We subtract 1 from both sides, and we see here that we're left with x is greater than 4, right? So this, we still have 4, like there, but now it's like what numbers keep this heavier than this side? It's all pounds or weights that are greater than 4 pounds, right? So 5 pounds would keep this heavier than 4. 6 pounds would. 7 pounds would. So that's what we mean by representing multiple numbers, right? So the solution are all numbers that are bigger than 4. And so if we connect this to some of the stuff we did yesterday, you're going to see some problems that say, for example, if you're buying some meat at $5 per gallon and you have to spend less than $20. And so yesterday we set up our inequalities. We chose the correct symbol. It's already here for you. We have 5x less than 20. And so if we're given these options, 1 pound, 3 pounds, 5 pounds of meat, 10 pounds of meat, we should be able to decide from the math whether we can buy that amount, right? Whether those are viable options. And so we're going to check which ones out of these 4 are actually correct. And so one way to do this is by solving. So we're going to solve the 5x is less than 20, divide both sides by 5. We know those 5 cross out, and we get x is less than 4. And so what does this x is less than 4 represent, right? So this is the amount of pounds of meat that you could buy. And so if we know the solution are all numbers that are less than 4, then we know that 3 pounds is less than 4 pounds. And we know that 1 pound is less than 4 pounds. Right? And that kind of makes sense because this less than 4 pounds of meat, those are less than 4. Nope. So that was by solving. We solved this inequality. And so we're going to do the same problem, but this time we're going to be plugging in our values, right? So we still have meat that's $5 a gallon. We still have to spend less than $20, right? And we want to check whether we can buy 1 pound, 3 pounds, 5 pounds, or 10 pounds. So instead of solving it and just looking at our solution, right, we're going to take that number, 1, 3, 5, and 10. We're going to plug it in, right? So if it's $5 a pound and it's 1 pound, then we can just actually see how much it costs, right? $5. Is that less than $20? $5 is less than 20, so that means yes, that is a solution. We do that for each one. We plug in 3 pounds. $5 times 3 pounds, that's 15, right? $15 is less than 20. There's another solution. We keep on going on the same pattern. We replace the x with this 5, and we get 25, which is not less than $20, right? So that is not going to be a solution. And then when you plug in 10 pounds, that's going to be $50, and $50 is more than 20, so that is not a solution as well. Right, so this was the example with dollars, with some actual context to help make sense of it, but we're also going to have some without any context at all. So if you want to know which values out of -2, -3, -4, -5, -6 are solutions to this specific inequality, then we can solve it. Right, so we're going to get the x by itself, and then we're just going to see our solution. We add 1. Those cross out. We divide both sides by -2 because that is multiplying. Those cross out again. And then we get x is greater than negative 4. So the sign flipped because we divided by a negative. And so this means that the solution are all numbers that are bigger than negative 4. So we think which numbers are bigger than negative 4? Negative 2, negative 3, nope, and nope. Right? Because these numbers are bigger than negative 4. That was by solving. Finish it up with the second method by plugging in. So this is why sometimes it's easier to do one method versus the other. With the other method, we can just solve it once and then look at the answers, whereas this one, we'd have to plug in our negative 2. We'd have to plug in our negative 3. We'd have to plug in our negative 4, negative 5, negative 6, and then we'd calculate each one, right? So we're actually going to we put this part in the calculator, right? That's the important thing. This part goes in the calculator, So that first one, negative 2 multiply negative 2 minus 1, that gives us 3, and that is less than 7. Negative 2 multiply negative 3 subtract 1 is 5, that is less than 7 as well. Right, we do each one, we multiply those. No, 7 is not less than 7, 9 is not less than 7, and 11 is not less than 7, which once again gives us our two solutions, negative 2 and negative 3. Thank you for listening.